Hey everybody, I find myself thinking a lot more and trying to think in a way to keep myself occupied, and I was thinking about space. So I've seen in a lot of videos, they show you like space as a grid, and when you put a planet on it, kind of sinks into it, and na 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 na, right? And I was thinking about uh, one of the famous philosophers or whatever, the tub and displacement, how when you get in a tub, it displaces water outside the tub. Then I was thinking to myself, well, what if someone were to hypothetically jump into a tub of water, but there was no outside for the water to go to? Um, we all know that water doesn't like compression. Uh, and in this theory of thinking, the water can't surpass its surface tension. But it has to allow someone in. So it would be pushing the water back into a theoretical space upon itself. So, and that thinking led me to think about space as squares. So, cubes, really. So, we'll say that the universe is divided up, the entire universe is divided up into little tiny cubes that all are right next to each other. And these tiny cubes are nothing more than made of lines. And we'll say for uh, what does each cube equate to? I would say each cube would equate to the difference in density matching its size. So if each one of these theoretical cubes was, say, 1 centimeter by 1 centimeter cubed, um, then it would have the potential gravitational energy equal to anything its exact size by density. So the denser the object is, the more of the cube it displaces, right? And it doesn't get displaced back onto space, it gets displaced as gravity. So each one of these 1 centimeter by 1 centimeter cubes by density equals displacement of space itself, which the displacement is equal to the gravitational force. So, like black holes, how do they exist and why do they exist and why do they look the way they do? Is that it is no longer able to displace gravity at its density. So instead of displacing gravity and having normal gravitational energy, it inverts. Uh, just like the spinning motor on one of my first little helicopters, if you held it, it would time out the motor somewhere in some sort of circuitry and reverse it. It wasn't great for a toy helicopter. I'm not sure why these motors or circuitry was chosen, but think about why a black hole looks like it would if you could see it, this twisted mass. Um, that doesn't make sense because, like, could I see it from front? Could I see it from behind? Is there an angle which you can't physically see it with any certainty? And so instead of being able to displace and create a normal gravitational flow, it inverts gravity upon the object. So the object is no longer displacing space. Space is now displacing the object. And that leads me to think about dimension. Uh, you pull up on a blanket and it's got these lines, right? I don't know if you can see what I'm doing here, but you pull up on a fabric and it doesn't want to go into what we think as like a twist. It's not twisting. But then I think about, well, if space is made up of all these little cubes and all these little cubes are being pulled in such a way that they can't displace, they start to displace the object. Four dimensions doesn't make sense. I know it's hard to say, but like, if it was displacing at all the surrounding four-dimensional points, and you know, I would think it would naturally take on a cubed shape. Um, I start thinking about planets. Why do stars and planets form as a round surface? You know, why does it? Why do we have the thinking about dimensions the way we do? Uh, so think about a bunch of stuff floating in a perfect gravitational environment. What shape would it take on? A sheet, a circle, a sphere, a cube, so on. And it got me to thinking, like, how many points would you need to pull from inside a dimensional fixture to get a perfect hole or black hole, sphere, round? It doesn't make sense to pull on it from 1 point, or 2 points, or 4, or 6, or 12, or 24. Theoretically endless? If you could pull on theoretically endless points from inside of a dimensional fixture to create a black hole on the obverse of gravity. So I think, just snowballing here, that dimension equates to sphere. Sphere equates to dimension. I'm not sure how you would do the math on spheres or rounded objects or just the symmetry of a black hole to come up with the number. But I think somewhere in what I'm thinking might be an idea for someone else to take and figure out. Like, is it possible we're looking at like fabric, dimension, space, time, too theory-like and not mind-like, like Einstein riding the bus, you know, and light not being able to catch up to him at light speed, right? Well, how many things in the universe are round, and why are they round? If space is displaced, and every time one of those little lines intersects on a three-dimensional object, there's an intersect point on the three-dimensional object suggesting at least 6 or more. I don't know if that makes any sense, but like, it almost seems like the idea snowballs out of control in my mind to the point where the numbers and the math and the thought of the little cubes filling up the entire space become, there's something there, but I just can't see what I'm supposed to be seeing. So it's just a thought. It's all could be kahooey and not mean a thing, or one day it could be the video someone watches and gets them thinking about something and they make the next breakthrough. Because I don't think some guy sitting here just thinking is ever going to get a Nobel Prize. But I think the way we think about space, time, and gravity and displacement, and I think just like jumping into a bathtub and displacing water, I think there's things that get displaced and come back on the obverse. It's, if I was to displace theoretical material out of theoretical space, but it can't create new space to be displaced into, and there's no space for it to be displaced into, uh, what would be the quantum effect of that displacement? And what would it look like? Would it look like gravity? The more of these little theoretical cubes we displace versus our density equals the amount of gravity that I feel on my feet when I hit the ground? Because we all know if this planet was made of solid gold, we wouldn't be here. We'd be pancakes. We couldn't exist. That density change on the planet would be astronomical in the sense of gravity, but it didn't displace more space. It just displaced more space well. And it's not like you plop it down and it displaces space out. It's a layering effect. I don't know, but I think basically the same as water gets displaced from a bathtub. The minute you put the earth here, it displaces space, and that displacement is the coefficient of gravity. And if you wanted to make, say, a space vehicle that could just take off the earth's surface, you would just have to figure out how to reverse the displacement of the displacement. So you know that we're displacing theoretical cubes of space, and if you wanted to, say, just fly straight up and not be affected by the displacement of that, how could you counteract the displacement of the displacement? Could you, say, make a theoretical void of new cubes that have a different displacement property? I don't know. It's up to quantum mechanics, I guess. Just a really weird video. So you made it to the end. Thumbs up. Another point for you. Hit the subscribe button. Kick it. I don't know. Just yeah.